What's up, y'all? So I hope you're doing well and during this quarantine time and you don't miss school too much. I'm sure you don't. But today we're going to talk about ScatterPlots, and I'm going to hit the main points and the main takeaways that you got to get from it. And then I'm going to, on the following slides, you'll see a couple questions I just need you to answer. All right. So with scatterplots are just going to be graphs that have a bunch of dots. Usually there's going to be something along the X and Y axis. There's usually be something along the Y axis, something along the X. But for the first part, I'm just going to show you the correlation part between the two. So when you're looking at the scatter plots, you want to try to see if something has a positive, negative, or no correlation. All right. And so the way you want to read it is you do it the same way you read any graph. You read it from left to right. All right, from left to right. And you want to see basically what's happening with the dots. All right, so let's say that we focus on number 5. If you look at number 5, starting from the left, and then as you move right, the dots tend to go down. All right, from left to right, the dots tend to go down. And so drawing a line, something like that, will kind of help you see it. And what we usually call this line is a line of best fit. A line of best fit. But yeah, so as you go from left to right, these kind of go down. And so since they go down, you would say that it has a negative correlation. And you do the same thing for each one of these. All right, you try to see if you can draw a straight line that's either going to go up or down and see whether it has a positive or negative correlation. All right, so something like this one would be a little easier. But as you can kind of tell, if we was just to draw a line straight through here from left to right. So as we go from the left to the right, these go up. So this has a positive correlation. All right, and this one's a little smoother, but if we look towards number 2 and number 3, so number 2 and 3 don't look as organized as these two down here, but you could still, if you were to look at it from left to right, our line, what it was like, what's happening with the dots. So if I was to draw a line of best fit through here, I would do something probably around there. All right. I got about the same amount of dots on either side, and it encompasses what's happening overall, the general trend of it. So from left to right, these are going down. So again, I would say that's negative. And so for this one, what's happening from left to right? So from left to right, I would say starting around here and going up through there. This line, even though it doesn't touch, all of the points or anything like that, it doesn't go through like a majority of the points. I have 1, 2, 3, 4 dots on this side and about 1, 2, 3, 4 dots basically on this side of it. And it's an even amount. So, but on either side, it's about the same amount of dots, and it goes right through the heart of the data. And again, so from left to right, this one's actually going up. So this one has a positive correlation. All right, so those are the main two. You should be able to either look at a graph and say, hey, this graph is going down, and so there's a negative correlation, or these are graph is going up, and it's a positive correlation. All right, and so if the dots are really close together like this one, then it's a strong negative correlation. Or really close together, it's a strong positive correlation. Whereas if it's weaker and it's a little more scattered out, you wouldn't say it's as strong of a correlation, but you say it can still be positive or negative. All right. But then you have the other case in which it's, as you look from left to right, we don't know what's going on over here. All right. So something like this, we can't really say it's either going up, or you can't really say it's going down or anything like that, too much of any change. So we just say no correlation. No correlation between the two. All right. Same thing with this one. This just tends to go in like a little circle over here. But this one also would say no correlation. We just try to figure out, we can draw a straight line and say whether it's going up, down, or there's like no correlation. All right. So that's just being able to tell. So one skill that you really have is say whether something has a positive or negative correlation. All right. But sometimes, though, for the most part, you do need to do some interpretation. So that's why I want to look at this one down here. All right, so with this one here, it says Mr. Thomas wanted to know if the amount of class time that he gave students to study affected their test scores. And the scatter plot below shows the results. All right, so a couple things you can do with this one. It's not the best graph, but a couple things. If you want to try to draw a line of best fit, you want to get way back here. All right, so let's say our line goes somewhere like that. All right. That looks pretty decent. I got enough here and there. So it's pretty solid. All right. So here's our line of best fit. From left to right, we would say that this has a positive correlation. All right. And then just taking this a step further, as we look at this, let's say that we wanted to have an equation that kind of like represented all of this. All right. If you wanted to get an equation, you would do the same thing that you would do with a regular linear line plot. You would simply take 2 points, find the slope, and then find your y-intercept and go from there. All right, so let's say that I chose, choosing 2 points. Let's say we chose this point. All right, this is 5 and about 72. So 5, 72. And the other point, I'll choose another point that's way over here on this side. I'll go for that one. This says 25 and about, let's say 86. 25, 86. All right, so we got 2 points that are basically relating to our line here on the scatter plot, and we're just gonna find the slope. So finding our slope, you want to do, here's your x1, y1, x2, y2, and then so from here, find your slope, do the y2 minus y1, so 86 minus 72. And then on the bottom, x2 minus x1, so 25 minus 5. So 86 minus 72, I think that's 14. And then 25 minus 5 is 20. So 14 over 20, we can reduce that. So divide that by 2, that's 7. Divide this by 2, and that's 10. All right, so 7 over 10 is what it will reduce to. Now, what does this correlate to over here? And remind you, we just found our slope. This is our slope. So the y values was our test score. So that's our test score. And on the bottom, we had our study time. Our x's were study time. So if we had to like interpret our slope here, we could say that for every 10 minutes of study time, your test score went up about 7 points. All right, that's one thing we can probably say about our slope here. All right, that's just one way to interpret like one thing that's going on here. But continuing going a step further, let's say that we still need to finish this out and we need to find our equation of the line. So just say y equals mx plus b. That's our m. So y equals 7 over 10 x plus b. And then if we had to figure out what the b is, we can plug in one of these points or choose any one of those points, whatever it needs to match up with our line. So, but I'm gonna I'll choose this one. So if I choose this one, that's 86 equal to 7 over 10 times 25 plus b. So 7 times 25 would be 150. So that's 150 over 10 plus B equal to 86. Handwriting's getting terrible here. All right, so 150 and, oh, I lied. It's definitely not 150. It's 175, right? Because 25 times 5 is 125, so 175. All right, 175. Now, 175 divided by 10, that's 17.5. So I'll come over here. So 86 equal to 17.5. Yeah. Plus B. Oh, shoot.